All right, so for section 16.5, it's going to be similar to yesterday's, except for these problems are going to have an a value. So in other words, they're going to have a coefficient in front of the x squared. In other words, again, that would mean a number in front of x squared. So when a is a perfect square, completing the square is simpler than in other cases. So what that means is when a value, we can take the square root of it and get a whole number. So in other words, it's a perfect square. Then we can complete the square to solve, and it's a lot simpler than the other methods we have talked about. The only difference between yesterday's and today's, yesterday we added b over 2 squared to both sides. Today we're going to add b squared over 4a. So b squared over 4a is our magical piece that we need today to solve these problems. All right, so here, again, we have to have the constant on the side by itself, and that is true here. So the first thing that we need to do is figure out what b squared times 4 or over 4a is equal to. So remember, our b is in front of x, so that would be 8 squared. And 4 times our a value is in front of x squared, so that would be 4. So that would end up being 64 over 16. And when I divide that out, that's a 4. So I'm going to add 4 to both sides of this equation. So that's going to turn into 4x squared plus 8x plus 4 equals, then we have 21 already on that side, so 21 plus 4 would be equal to 25. Now we can take the square root of these. Square root of 4x squared would be 2x, and 4 is 2. So this is all addition. So this would be 2x plus 2 squared equals 25. And then just like yesterday, we have to take the square root of that. And we would end up with 2x plus 2 equals a positive or negative 5. So we have to split it into two problems. 2x plus 2 equals positive 5. And 2x plus 2 equals negative 5. And then we solve these. So we subtract 2 from both sides and then divide by 2. So x equals 3 halves. And then on this one, same thing, subtract 2 from both sides and divide by 2. So we have 3 halves and negative 7 halves for our 2 zeros for our answers here. All right. When the leading coefficient is not a perfect square, so when that number in front of x squared, the a value, is not a perfect square, we can transform the equation by multiplying both sides by a value so that it does become a perfect square. So right now I have 2x squared. So the next perfect square that I can get to is 4. So I'm going to multiply everything by 2 so that that becomes 4x squared. So I would have 4x squared minus 6x, oops, not minus 6, it'd be minus 12 equals 10. And then we can do the b squared over 4a. So b is negative 12 and a is 4. So negative 12 squared is 144, and 4 times 4 is 16. And 144 divided by 16 gives us 9. So we're going to add that to both sides. And then we're going to take the square root of the first and last term. So this would be 2x, and this would be 3. Now this is a subtraction equation. So we're going to have 2x minus 3 squared equals 19. And then we have to take the square root of both sides. So we're going to be left with 2x minus 3 equals square root of 19. We can't do that, can't simplify 19, so it's just going to be positive and negative square root 19. And then we have to break it into our two equations. So 2x minus 3 equals a positive square root of 19. And 2x minus 3 equals the negative square root of 19. So I am going to add 3 to both sides. We're going to have 2x equals 3 plus the square root of 19. And then I'm going to divide everything by 2. So x equals 3 plus square root 19 over 2. And for our other equation, we're going to add 3. So we have 2x equals 3 minus the square root of 19. And then we have to divide by 2. So x equals 3 minus the square root of 19, all divided by 2. So there's our two exact answers. Again, we could find the decimal and round, but we want exact answers. All right. Last question here. Says the height and feet h of a baseball thrown into the air from a starting height of 5 feet with initial velocity of 64 feet per second can be modeled using the equation h equals negative 16t squared plus 64t plus 5, where t represents the time in seconds. How long will the ball remain in the air? So in other words, we have to solve this and find the zeros. So the first thing that I notice is that it's not equal to our constant number. So we have to subtract 5 from both sides. So we're going to have negative 16t squared plus 64t equals negative 5. And then we don't want a negative out front because we can't take the square root of a negative. So we're going to factor out a negative 1. So that just makes everything opposite. Dividing by negative 1 equals 5. And then we're going to focus on what's inside of the parentheses. We are going to have to figure out what our c value is. So we do have 16 out front, so we can take the square root of that, so we're in good shape. So b squared over 4a. b is negative 64, and a is 16. So when I do all of that, 64 squared divided by 4 times 16, I get an answer of 64. So we're going to ignore the negative 1. It's not going to help us out anymore. And we're going to add 64 to both sides. And 64 plus 5 is going to give us 69. Then we take the square root of both sides. So we have 4t and 4t and 8 and 8. And it's a subtraction problem, so it's going to be 4t minus 8 squared equals 69. And we take the square root of both sides. So 4t minus 8 equals positive negative square root of 69. Break this into two different problems. Positive, and I'm running out of room here, negative square root here. We're going to add 8 to both sides, so it's going to turn into 4t equals 8 plus square root of 69. And then we have to divide everything by 4. So t equals 8 plus the square root of 69, all divided by 4. And then we have to add 8 to both sides here, so it's going to be 4t equals 8, and then negative square root of 69. And then divide everything by 4. So we're going to have 8 minus square root of 69, all divided by 4. And since this is a word problem, we are going to figure out, we're going to round. This first one, when we plug it into our calculator, we're going to get approximately 4.08. And the other one, when we plug it into our calculator, we're going to get negative 0.08. So the question was, how long will the ball remain in the air for? Well, it's definitely not going to be this negative 800. So this ball is going to stay in the air for approximately 4.08 seconds.